Hello, everyone. Welcome to your ticket to retake your topic 1B test. I'm just going to go through and talk through these problems. So let's get started. All right, so number one, we have to solve and graph the inequalities. So what we want to notice is we have just one inequality. It's not a compound, so we're going to be able to solve for x. We'll have one circle on our number line to represent our solutions. Versus if we notice down here, this is a compound inequality that has two inequalities in the same problem. Here's another compound inequality. So just wanted to highlight the difference there. So we can approach this like solving, how we would solve an equation. On the left side of our inequality, we have some like terms we want to put together. This 0.5x and this negative 2x, we're going to put those together. So 0.5 minus a 2x is a negative 1.5x. We'll carry down our plus 8. This is a greater than negative 4. Now that we have the x's together, we're just going to solve for x. It's a two-step equation at this point. We always start by subtracting, taking care of any of that addition or subtraction. So 8 minus 8 is 0. Negative 1.5x is greater than negative 4 minus 8 is a negative 12. Our last step is going to be to divide by this negative 1.5. Now, anytime that you divide by a negative number, so right here we divided by a negative number, that is going to flip your inequality. What's tricky about it is we just have to remember that on our own. There's no little like reminder in the direction. We just have to remember that with an inequality, when you divide by a negative, so I'm going to carry down the x instead of a greater than, now we're going to have a less than. And then negative 12 divided by a negative 1.5 is a positive 8. So here's our solution. X is less than 8. So what that means is that any number that's less than 8 is a solution for this inequality right here. When we put that on a number line, here is just relative to other numbers. We're going to have a 7, an 8, and a 9. This is going to be when you have just less than or greater than without the or equal to. So if you look right below, here's an or equal to, just to show the difference between those. The or equal to is a closed circle, which means that your solution can also equal that value. But if it's just a less than, this is an open circle. So we put an open circle on 8. And then we're going to shade the solutions. And our solutions, x represents all the solutions, and those are going to be less than 8. So as you look at a number line, I could shade to the right where the numbers are getting bigger, or I could shade to the left where the numbers are getting smaller. And we want to shade to the numbers that are less than 8, so that is going to be to the left. All right, so we solved our inequality and we graphed it. Let's move on to number 2. Number 2 is another simple inequality with just one, but we've got some simplifying and solving to do here. First thing that I notice is some distributing. This first x is going to carry down. This is a negative 3. So when we distribute, let's be very careful with our signs. This is a negative 3. We're going to distribute it and multiply it with a negative 2. So the negative times the negative is a positive 6. And then we have a negative 3 times a negative x. So that negative times a negative is a positive 3x is greater than 2x plus 8. Just carry that down. Now I notice that on the left side of our inequality, we have like terms. We can add those together. X plus 3x is 4x. Plus 6 is greater than 2x plus 8. The next thing I notice is I've simplified everything on the left. Everything on the right is simplified, but we have the variables on both sides. So we want to get those to the same side first. We could subtract 4x or we could subtract 2x. I'm going to subtract 2x. It wouldn't be wrong to subtract 4x, just our steps would look a little bit different following this, but we would get the same answer in the end. 2x minus 2x is 0, so we cross those off. 4x minus 2x is 2x. Carry down our plus 6 is greater than 8. All right, now we have just a two-step inequality to solve. We are going to subtract 6. We have 2x is greater than 8 minus 6 is 2. And then our last step is to divide by 2. I'm dividing by a positive number, so that means that my inequality will not flip. It's going to stay exactly as it is. So we end up with x is greater than, and then 2 divided by 2 is 1. So x represents all of our solutions, so any numbers that are greater than 1 would be a solution for this inequality. We're going to put that on a number line. 1 is in between a 0 and a 2, so here's 0, 1, 2. We're just showing where it is relative to other numbers. That is a greater than. It does not have the or equal to, so we're looking at another open circle. And then when x is greater than 1, remember x is representing all of our solutions. Any number that's greater than 1 is a solution, and the numbers that are greater than 1 are heading to the right here. So our shading is going to go to the right. All right, number 3. So here's a compound inequality. We can see it's connected with the word or. We've got this one on the left or this one on the right. So what we do is we solve these separately. We're going to solve this one. We're going to solve this one. This or is going to carry down and be part of our answer. We can predict that we'll have 2 circles on our number line. Ors, when they behave, will shade away from each other. So that's what we can predict is going to happen. If it turns out a little bit different, we'll cross that bridge if we get to that. But let's just go ahead and start solving. For this one on the left, we have some distributing. Positive 2 times positive 4x is positive 8x. Positive 2 times positive 3, positive 6, is greater than or equal to negative 10. Then we just can start solving for x. We'll subtract 6. So 8x is greater than or equal to negative 10 minus 6 is a negative 16. We go back to the x. We're going to divide by 8. Now, I said in the last couple problems that sometimes you're going to flip your inequality. Do you see how this is a negative 16? The numerator, it doesn't matter if this number is positive or negative. It's what we're dividing by. So this number in the denominator that you're dividing by, if this is negative, your inequality will flip. If this is positive, then it's just going to stay exactly as it is. So we are not dividing by a negative. So x will stay as a greater than or equal to. Negative 16 divided by 8 is negative 2. I'm going to carry down the or from the problem, and then we're going to solve the inequality on the right. There's no distributing to do, no like terms. We can go ahead and start solving by adding 15 to both sides. Negative 15 plus 15 is 0. We'll carry down a negative 5x is greater than 5 plus 15 is 20. Let's divide by a negative 5. So here we are dividing by a negative number, so our inequality is going to flip on this one. I'm going to go ahead, those are going to reduce to 1, so we have x is, instead of greater than, we're going to say less than. 20 divided by negative 5 is negative 4. So here's our solution, and then we're going to put that on a number line. We're going to have 2 circles, a circle at negative 2 and a circle at negative 4. So I want to have, here's negative 4, negative 3, negative 2, maybe I'll throw a negative 1 on there also. So the circle at negative 2, x is greater than or equal to, so that's going to be a closed circle at negative 2. What that closed circle means is that negative 2 is a solution, and any number greater than -2. So that -2 is included in the solutions for this. We're going to shade all of our x's that are greater than the -2. Again, on a number line, the bigger numbers are heading to the right. So we're going to shade everything to the right. Or x could also be less than a -4. So we're going to put a circle at the -4. This is a less than, so that's going to be an open circle. And then we want to shade all the numbers that are less than -4, which is shading to the left. Those are all of our smaller numbers. Okay, number 4, we have, this is a compound inequality. Do you notice how we have two inequalities? That's what makes it a compound, and it's all connected. One, we don't see the word or, so this is not going to be an or. This is a very common way to represent an and inequality. All right. The way that I see this is we have 3 sections. We've got this section on the left, we've got this section in the middle, and we've got this section on the right. Your variable will always be in the middle section for an and inequality. Our goal is to get the p alone in the middle. So any numbers that are in here with the p, we have to get out of there. I can see that p is being multiplied by a 2, and we're also subtracting a 3. So we always start our solving with addition or subtraction. So if we're subtracting 3, we want to add 3, because -3 plus 3 is 0. Now, what we're used to doing is adding 3 to the other side. So here we are adding 3 to the other side. But in an and inequality, you have the other side right here, and then the other side over here. So basically what you're going to do is we're going to add 3 in all 3 sections. We're adding 3 in the middle, we have to add 3 on the right, and we have to add 3 on the left. What I want you to be careful about is this one on the left. This is the one students most commonly forget. Add 3, like this feels natural to you guys, but we have to remember to add 3 on the left as well. So we should see adding it in all 3 sections. This -3 plus 3 in the middle equals 0, so we cross that off. On the left, we have 3 plus 3, which is 6, is less than, I'm going to carry down the 2p, which is less than or equal to 11 plus 3 is 14. Now we go back to the middle. We are trying to get the p alone. P is being multiplied by a 2. So to solve for p, we are going to divide by 2. And we divide by 2 on the right, and we divide by 2 on the left. Whatever we're doing to solve, we have to do in all 3 sections. 2 divided by 2 is 1. So we got the p alone. So let's just write our final inequality. On the left, we have 6 divided by 2, which is 3, is less than, we got our p alone in the middle, which is less than or equal to 14 divided by 2 is 7. All right. So on a number line, we're going to have a circle at 3 and at 7. So when I think about what I have to fit onto a number line, we want to fit a 3 and a 7. So here's 3, 4, 5, 6, 7. So let's take a look at this right side. If I ignore, kind of cover up this left side over here, we're saying that p is less than or equal to 7. So that means that I need a closed circle on 7 that or equal to, that's the piece that tells me it's a closed circle. So closed circle on 7, and then when it says p is less than or equal to 7, we want to shade all the numbers that are less than 7, which is going to be to the left. Those are our smaller numbers. So the shading is going to go like that. Now, if we ignore the less than or equal to 7, and let's just take a look at this. Notice how if I start with the p, I have to read it backwards. This says if I start it with a p, p is greater than 3. Again, I'm reading it backwards, so I have to read the inequality backwards as well. So this is saying P is greater than 3, which means we need a circle on 3. It does not have the or equal to, so that's going to be an open circle. And then the values that are greater than 3 on a number line are the ones going to the right. So we're going to shade to the right. And then what happens is we can just go ahead and connect these. With this and inequality, any number that is less than 7 and greater than 3 at the same time would be a solution. And those are going to be all the numbers between the 3 and the 7. So a solution for P is representing all the numbers that are less than or equal to 7 and also greater than 3 at the same time. That's how we want to think through that and compound inequality. All right, number 5. We have to solve one more inequality. This one has some distributing, so that -3. Remember, when we distribute, we're paying close attention to our signs. So -3 times a positive W is a -3W. -3 times a positive 3 is a -9, is less than or equal to 9 minus 3W. Okay, so we did our distributing. We do not have any like terms to combine. We do notice that we have W's on both sides of our inequality, so our next step is going to be to get those to the same side. On the right, we are subtracting a 3W, so I'm going to add 3W. I'm going to add 3W to its like term over here. Now the reason why we added 3W is because -3W plus 3W, that equals 0, so we're going to cross that off. And then what you guys are probably noticing is, well, here's a -3W plus a 3W. That also equals 0. So we cross that one off. So what just happened is our inequality, or our variable, is gone. There's nothing left to solve for. We don't have a W to solve for. So when this happens, our solution is going to be either no solution or all real numbers or infinitely many solutions, however we want to phrase that. So how do we know which one it's going to be? Well, what we're going to do is we're just going to carry down whatever's left over in our inequality. So on the left side, we have a -9. We want to be very careful that we notice that that is negative. And then we're going to carry down our inequality, and then we carry down what we have on the right, which is a +9. And then we just ask ourselves if this is true. Is this a true statement? Is -9 less than or equal to 9? So for this to be true, -9 could be less than 9, or -9 could equal 9. If one of those is true, then this is a true statement. So -9 is less than a +9. So this is true. That means that every single number on the number line is a solution. So we can say all real numbers we could say infinitely many solutions. We have a couple different ways to phrase that. On a number line, though, how do we graph? I just put 0 on there just to put a number on there. We don't have a circle. You know, we didn't have W is less than 5 to have a circle at 5. We don't have any circles to put on our number line. We just want to show that every single number would be shaded. So that's just going to look like this, where I'm just shading all of the numbers. So we could plug in, if we think about what we're saying, if we go back to our original inequality, we could put in any value for W, and this left side will always be less than or equal to this right side. That'll be true every single time. All right, we just have 2 more questions on this front page. Number 6 says to write a compound inequality. We can see we're using the word compound because we have 2 inequalities on our graph. So When we have this, I can see that we have a circle at 0 and we have a circle at 3, and everything in between is shaded. So when we're shading in between our two circles, this is what an and inequality looks like. All right. So when we have an and, we saw one up above. Um, and is the one that has our three sections. In the middle is going to be our variable x. Over here on the right side, we're going to talk about this right side. We have an open circle at 3 and we are shading to the left. So all of the x's are less than that 3. So we're going to say x is less than 3. Now if we talk about this side over here, we have a closed circle at 0 and all the shading is going to the right, to the greater than. So if I were to just kind of write that out, I'm saying that all the x's are greater than or equal to 0, or equal to because of the closed circle, it's filled in. But I want to put this over here. Do you notice that x is greater than or equal to, so it's opening up to the x, and I've got the 0. What that's going to look like is the 0 is going to go first. I'm just going to write it backwards. And the 0 is smaller, so less than or equal to the x. This right here is the same as this right here, but now I've just connected it into a compound inequality statement. All right, number 7, I can see that the shading is, we've got one inequality greater than 1 and another one less than a -3. So this is what an or inequality looks like. When we write an or, we are going to write an inequality for this shading. We're going to write an inequality for that shading, and we're going to put the word or in between them. So one thing I notice students do is get a little mixed up when they're writing an inequality from a graph. So here's my advice. We can see that we're going to have, we have a circle at -3. So I want you to put the x on the left and the -3 on the right, and then let's figure out what inequality goes in the middle. That's just going to make the most sense for us to read. X is either greater than the -3 or less than the -3. We're shading all of the smaller numbers, so this is going to be less than. And do you see how it's an open circle? That means we don't have the or equal to, so just less than. I'm going to bring down the word or. Now here we have to write an inequality for this. So I'm going to have, we have a closed circle at 1. So we'll follow the same thing we just did. I'm going to write the x on the left, the 1 on the right, and I'm going to fill in the inequality in between. So because it's a closed circle, that means it's either less than or equal to or greater than or equal to. We have to include that or equal to. And then we just have to see, well, which numbers got shaded? X is representing the shading. Did we shade the numbers less than the 1 or did we shade the numbers greater than the 1? We can see that we're shading all of the bigger numbers. So all of our X's are going to be greater than or equal to 1. And this is our inequality, our compound inequality that represents that graph.